So our objective for 2.5 is to use algebraic properties and logical arguments. The 2.5 properties from algebra that we're going to use are the addition property. These are properties of equality because you have an equal sign in the equation and you're adding the same thing to both sides. So addition property, I add C to both sides of the equation. Subtraction property, I subtract the same value, in this case C, from both sides of the equation A equals B. And multiplication property. With the multiplication property, I multiply both sides by the same variable. A times C equals B times C. I multiplied A and B both by C. Division property. I divide both sides by the same value. As long as it's not 0, because we cannot divide by 0. Substitution property. If A equals B, then A can be substituted for B in any equation or any expression. So anytime I replace one variable with another variable that is equal to it, then that's substitution. Distributive property. With the distributive property, it involves parentheses, and we've got A, parenthesis, B plus C. I distribute the A to both the B and the C. It becomes AB plus AC, where A, B, and C are real numbers. Distributive property. So we have to use these properties to provide reasons for each step in solving this equation. So our first step is we write the original equation, and then the first thing you're going to do is get rid of these parentheses by using distributive property. So if we gave these reasons, this would be given. And when I distribute the 3 to this expression and 2 to that expression, that's distributive property. Okay, the next step, I combine like terms. So this is, and this causes, you'll have to get used to this, but when I take 6x plus 4x and I make it 10x in the next line, I am substituting. All right, we call that substitution. I'm replacing 6 plus 4 with 10. So it's the same value, it's just a different way to state it. We call that falls under the category of substitution. So I combine the 6 and the 4 like terms, and then we combine when we combine the 3, 2, and 7 and make it 12. That's substitution. So anytime you combine like terms, we're going to call that substitution. Zach, you need to have your head up, take notes. the next step. They didn't show that step, but what happens is the 10x becomes 15x, and this 5x, negative 5x becomes 0 because I added 5x to both sides. If I add the same number to both sides, that's addition, property of equality. So you can write addition. Now really I think they skipped a step. Ideally, right in here, they would have this step. They would have 10x plus 5x. Oh, shoot. They'd have 10x plus 5x plus 12 is equal to 42 minus 5x plus 5x. All right, if they do it that way, you would call this step addition, and then this step where you make the 10x plus 5x 15x, I'd call that substitution. If they don't show that in two steps, then just call it addition. The next step, we subtract 12 from each side. And end up with this. That's subtraction. And then finally, we divide both sides by 15. That's division, property of equality. Any questions? No questions. Okay. So we're going to do this one and give the reasons for each step. So we start out with 2x plus 3 equals 9 minus x. When you write the original equation, that's given. Okay, the next step is, what do you think we would do at the next step? There's several things you could do, but what if we filled in these blanks? What do you think is happening here? We usually want to get the variables on one side and the numbers on the other, right? So what are they doing here to do that? Okay, they're adding x. We would add x here and add x here. So we would have plus x on each side, add x to each side, and that's going to be addition. Property of equality. If I combine like terms, what like terms would I, from this equation to this, what would I combine? What would I make the 2x plus 3 plus x side? What would I make that? When I combine like terms in that side of the equation. My like terms are the x's, so what would I end up with? Yeah.
3x.
Yeah, I'd have 3x plus 3. 3x plus 3. We do the same thing on the other side. We add the negative x and x, and it's the x goes away, right? They cancel each other out, so it equals 9. When we combine like terms, what do we call that? Yes? That's where we use substitution. Good. That's substitution. What do you think the next thing we would do to solve this equation would be? It's our next step. Yes?
Subtract 3.
Yep, we would subtract 3 from both sides. So we have 3x equals 6. We're subtracting 3 from both sides, so we'd call that subtraction. Last step, what are we going to divide both sides by? 3x equals 6. What do I divide both sides by?
3x.
Not x, just 3. Yeah, just 3. We divide both sides by 3. And we're going to end up with x equals 2. Divide both sides by 3. So that's going to be division. Okay, questions? No questions. Very good. All right. Go ahead and try to break this one down yourself. Do it step by step, and then we'll go over it as a group. All right, give it reasons. Don't just solve the equation. Write reasons out to the side for each step that you do. I know you can solve the equation. I want to see if you know the reasons why you do each step. Go solve the equation. All right, let's work through this. What would have been your first step in solving this equation? What do we do first? Yeah. Yeah, we always want to get rid of the parentheses. So we would do distribute. So the first thing, this is out to the side here. This is given. And then we've got, it's a good idea to number the steps so that you can see what lines up. So we'll call that step 1 is given. Step 2, like Gage said, we distribute. So we have 14x. And then 3 times 7 is 21, so plus 21. And 3 times negative x is minus 3x equals negative 1. And that's distributive property. Okay, a couple of different things we could do at the next step. What did you do? What did you do next? Well, why don't we combine the like terms? The 14x and the negative 3x. We combine those. So 14x minus 3x is 11x. So we have 11x plus 21 equals negative 1. Right? And that is, when I combine like terms, what do I call that? Substitution. Right? What could I do next? Yeah, we want to subtract 21 from each side, so we have 11x plus 21 minus 21 is equal to negative 1 minus 21. That's subtraction. Right? And then we combine the like terms, or simplify, so we'd have 11x equals negative 22. What would I call that step? Okay, when I combine the 21 minus 21 and it becomes 0, and negative 1 minus 21 becomes negative 22, that's substitution. Now, thinking about this being consistent with what the other proofs were like, they may just do that they may combine these two steps. They may go straight from here to here, right? And they not show the minus 21. If they do that, okay, then you would just call that step going from here to here, you would just call that subtraction. You would leave out the substitution label. All right? And then the next step, okay, we have x equals negative 2. What do I do? What's that step called? What are we doing when we do that? Yeah, that's your division step, yeah. I think what I'm going to do is go ahead and take this. I think that on the assessments, how they'll do this is they will not have this step. Let me erase that. Not have that step, and then they call this subtraction. So this would be 4, this would be 5, and they would call that subtraction. All right. Let's see how they did it. don't put length the same value, put substitution. And they subtract 21 from each side. Yeah, they skip that step too. The step that I erased, they didn't have it. So that's how we'll do it. When you go from here to here, just know in your mind you're subtracting 21 from both sides. So that's subtraction. And then the last part is division. X equals -2. All right, reflexive property of equality. Real numbers. For any real number A equals itself. If something equals itself, you call that reflexive. For segment length, AB, if this is saying the length of AB equals the length of AB. So this segment is length AB. Then angle measure. Angle measure equals the measure of angle A equals the measure of angle A. So anytime you say something equals itself, you call that reflexive. Symmetric property of equality. For symmetric property of equality, for any real numbers A and B, if A equals B, then B equals A. You're just changing the order of your equality, but you're saying basically the same thing. We don't use symmetric very much. We'll use reflexive quite a bit when we start doing proofs, but symmetric is not used very often. If it's segment length, if AB equals CD, then CD equals AB. An angle measure, for any angles A and B, measure of angle A is equal to the measure of angle B, then the measure of angle B equals the measure of angle A. Just remember on symmetric, you're changing the order of your equality. Transitive property. This is an important one. It involves three things. For any real numbers A, B, and C, if A equals B and B equals C, then A equals C. All right? If A equals B and B equals C, then A equals C. It's a chain. Both A and C equal B, so they equal each other. Something we've recently used, what uses this pattern? Where have we seen this before? What is this similar to? One of our laws. Okay, this is like the same pattern as law of syllogism, isn't it? Right? You take the first if and the last then, and you join them. That's what you're doing here. If A equals B, your if is A, and then if B equals C, then A equals C. Okay? It's a chain reaction. Segment length. If AB equals CD and CD equals EF, then AB equals EF. Same pattern. Angle measure. If the measure of angle A equals the measure of angle B, and the measure of angle B equals the measure of angle C, then A equals C. Any questions on transitive? Let's try put some of these into play. Try a geometric proof. Okay, so we're going to show that we have to show that CF is equal to AD. All right, we have to show those two are the same. Okay, we're given in the picture, what is AB marked congruent to? What is AB congruent to? Look at the picture. It tells you. Yeah. How'd you know that? Yeah, the tick mark. This has one tick mark. EF has one tick mark. So we know that AB equals EF. That's given. We know that BC equals what? Yeah, Faith. DE. That's given, as marked in the picture. So we've got these two things equal. These two things equal. Right? AC. This AC equals AB plus BC. One of our first theorems. What are we doing there? When we say AB equals AC equals AB plus BC. Take two sections of a line and make the whole section. Faith. It's not substitution. Okay, that's segment addition. That's segment addition property. All right. Next step. DF equals what? What does DF equal? Very similar to the previous step. Yeah. Yeah. What did you say? EF, yeah. DE plus EF. We did the same thing just on the other side of the other end of the segment. And that's segment addition postulate. Next step, DF equals BC plus AB. You have to look up at your previous steps. This comes from previous steps. How were we able to do that? What told us we could do that? All right, if you look back, DE. Up here we said DE equals BC, right? So if DE equals BC, then I'm replacing the DE with BC. I'm substituting. EF, we look up here, EF equals AB. So I replace the EF with AB. Substituting. Right? So that's going to be substitution property of equality. Anybody see what I do on the next step? Again, looking back at the previous steps, what I wanted, yeah, go ahead, Carly.
DF equals AC.
How'd you know that, Carly?
Because AB.
From this step right here, right? Right. She looked back and so we're going to look for someplace else where we have BC plus BAB. Right here we have it, and that equals AC. So I replace these two with AC. All right? So DF equals AC, and that's going to be substitution as well. What do you think my next statement's going to read? I'll tell you what the property we use. If we use addition property, we use addition property of equality because we added CD to both sides. What goes in the blank? We had to go from this step to this step. I added addition property, CD to each side, so the AC is what goes in that blank. So we've got we added CD to both sides. And then your last step is always going to be what you had to prove. So I know, and it makes sense, DF plus CD, let's look at DF plus CD. DF plus CD is equal to CF, right? So that we're substituting that with CF in for that. And then we've got AC plus CD equals AD. That's there. So we put in AD for those two. That's substitution. Questions? Okay. So here we go through it. All right, that's where we're going to stop.